I now want to dive into chapter 2 of my new book, The AI Human Edge. And this chapter is probably the heart of the entire book. So we get right into the meat right away. And this is how we are going to build entity propensity models around each of our domain experts and the people they serve in order so that we can use AI to help elevate their expertise and unleash some of their creativity. And it all founded and starts with a concept I call nanoeconomics. This is a concept I developed, I don't know, probably two decades ago when I was working at Yahoo. And this is the idea that the you can build decision models, economic decisions models at the individual level. Individual being whether it's a human, nurse, doctor, athlete, a detective, social worker, a device level, a compressor or a chiller, or a treatment like a campaign or marketing campaign or cancer treatment or et cetera. And so the idea here about economics, about nanoeconomics, is we can actually get down to what I call the economic theory of individual entities' predicted behavioral and performance propensities. And it allows us to really get down and monetize not the volume of data, but the granularity of data by understanding these individual entities' predicted behavior performance propensities. And we're going to codify those into entity propensity models, or EPMs. If you think about how the flow of an EPM works, is we're going to identify an entity around which we want to build a model. Again, it can be a doctor, a nurse, a patient, a lawyer, their client. We're going to gather a bunch of context around that entities. We're going to understand historical performance and behavioral data, and we're going to use it to build a series of propensity scores that sit inside this entity model that we then use to drive decisions. Very well-formed, very thoughtful, very responsible decisions. Again, the EPMs are the building blocks of this nano-economic decision intelligence, right? Allows us to adapt strategic thinking at the individual entity level. So we're basically making decisions at the entity level, not at the average level. Right? This is one of the big differences between nano-economics is we're not making decisions based on averages. We're making decisions based on entities' predicted behavioral and performance propensities. Allows us to make real-time decisions in context of the situation, and allows us to really augment with data, the human intuition and human expertise. Key point here. We use both predictive AI and causal AI to help us build these entity propensity models. Predictive AI is used to help us identify potential patterns, trends, and relationships in the data that might be causal factors, that might be factors that are going to drive the cause and effect for the outcomes we're trying to drive. Predictive AI by itself won't give us that. It'll tell us some correlations that we want to check into, in which case then we actually apply causal AI. We use some of the causal modeling techniques to understand, for example, in this example, the impact of a training load has on fatigue, which has on injury likelihood for an athlete. Right? The big difference here is prediction. Predictive AI using correlations allows us to flag these potential factors, but causal AI allows us to explain and invoke, cause and effect, and be able to invoke things like intervention and counterfactuals and what if scenario. And right, we're going to dive into this in much more detail in chapter 5, but it's very important to understand that we use both predictive AI to help identify factors that might be causing impact, and causal AI to really quantify the cause and effect. We also use knowledge graphs here. Knowledge graphs are a valuable source of information because most knowledge graphs are built at the entity level. So they have very much an entity awareness. It allows us to build critical relationships between entities and the activities they do, both from a behavioral and performance perspective. It allows us to look at temporal context, time, right? Making a decision about what we're doing now, making a decision has impact a week from now, a decision has impact a year from now, and understands those temporal differences in doing that. And then causal structuring to understand why behavior shifts, so we can start using causal AI to do what if analysis, to do the intervention, to do the counterfactual. So knowledge graphs are a very important component tool that we use in building these entity propensity models. So here's an example of one we developed for Mike Trout. If you don't know Mike Trout is a superstar baseball player, plays for the Los Angeles Angels, And this is an example of what you would want to build for Mike Trout, right? You think about entity themselves, all the propensity scores we want to know about Mike Trout. His performance in high impact situation, how good he is at pitching the effective pitches to swing at, base base state performance, and how productive he is in moving runners around the bases. And so there are a bunch of propensity scores we want to build about him, right? His probability of hard quality contact, etc. And we'd create a score of that, use a bunch of data sources, and then we would use those scores to help us make precision decisions at the point we needed it, like in lineup construction or trying to figure out what's the right kind of matchup for him from a batter perspective, or even things around health and maintenance and such. So we use all this data, and these entity propensity models can get very long. You build a lot of propensity scores, and these scores all interplay with each other as you try to figure out, how do I use, in this example, Mike Trout most effectively in baseball games, and what situations, and when do I hit and run, and when do I swing away, and right. So again, I'm using this information in real time to make decisions in the entrance of the game. I'm using them to make intermediate decisions about do I rest in between games, and maybe I'm making these decisions on a season basis regarding development and keeping him, a top operating form. These same concepts work for any domain expert, not just baseball players, not just basketball players, not just athletes. They work for nurses and doctors and teachers and architects and operators and engineers and lawyers and detectives, and anybody, any place you've got domain expertise, human domain expertise, we can start to capture information at their individual level, because every individual is different. If we look at nurses, for example, some nurses are better in some situations. Some of them have more experience in handling certain kinds of treatments and being good counsel for a patient who is under stress. So again, these same concepts, these entity propensity models, we can build on every individual. And the reason why we do this, the very heart of the book, is that if we understand what everybody's strengths are and what their potential is, that we can use AI to help elevate their expertise by giving them the right kind of guidance, and also unleash some of that imagination and creativity that's inside of each of us to help them to develop even further, to provide more relevant outcomes, to be more creative in the situation. So while a lot of the book talks about athletes, you'll see the book talks a lot about other domain experts who also can benefit, so we can make every nurse a better nurse. We can make every nurse the best nurse they can become. Every doctor, every teacher, if we take this approach of building very detailed models. And I know it takes a lot of work. Right? You think, well, I'm going to have to do all this, invest all this time in my employees to learn all about them. By golly, you are. Because one of the premises of this book is that the most valuable asset in your company are your employees. Why wouldn't you want to get the most out of your operators, your frontline sales agents or sales reps and customer service agents? Why wouldn't you want to get the most out of them? And AI can help them, can help provide that sort of guidance. Here's the obligatory technology stack that we would look at with data and feature engineering. Books talks about that, so I don't need to talk about it. But I do want to end on this point, that there are some very important economic, modern day, data-driven economic concepts that are playing a major role today. One of them is called the marginal propensity to reuse. That is, I can build a propensity score for a nurse, for example, and use that propensity score regarding her fatigue, regarding her level of experience, regarding her level of interest in a certain area, and combine all these scores to reuse them across different situations, different use cases, right? Making sure that they're assigned to the right cases at the right time of day and the right patients. And the second one is this marginal propensity to learn, the ability to learn and adapt, that these assets, using AI, this is the real point of AI. With AI, I can build assets that continuously learn and adapt. And my AI models that I've got paired, that these entity propensity models that are paired with my nurses and doctors and teachers, are constantly learning as they go through. And as they learn, they're helping to elevate and amplify the capabilities of the human. So this chapter 2, is meat and potatoes for the book, right? It is the heart of what we're trying to do. If you don't understand chapter two, the rest of the book isn't going to make any sense. And chapter two is based on a very critical component that you must believe that the most important in your asset in your organization are your employees. And everything we can do with AI to improve their effectiveness, to improve their efficiencies, to improve their ability to identify and create use their creativity to create new solutions benefits them, elevates them, and benefits the organization in which they're a part of. Anyway, end of chapter two. Thanks.